Simple mathematical operations commonly are used with polynomials. So let me just run through a couple examples here of how we can add and subtract, multiply, and distribute with polynomials. First things first, let me set up a polynomial here that would need to be added or subtracted with something else. This is an example of a trinomial that must be summed with another trinomial. And anytime that we add or subtract polynomials, we must combine like terms. That's the key here. And when I address like terms, the variable and exponent must match. That's what would indicate a like term. So this x squared number can combine with this x squared number. X squared and x squared are similar, so we would call those like terms. Now, looking at the sign in between the two polynomials, we have a 3x squared plus 2x squared. If I have 3x squareds plus 2x squareds, that leaves me with 5x squareds. Next, I have a 2x that should be combined with a negative 6x. Those two are like terms because the variables match. 2 plus a negative 6 leaves me with a negative 4x. And lastly, 3 plus negative 2, the like terms here because the variables would match. Both of those variables are x to the 0 power. 3 plus negative 2 is a positive 1. We would say that the sum of these two polynomials, or trinomials more specifically, is 5x squared minus 4x plus 1. We could have a problem that's slightly more difficult. Let me set one up for you. Here's a pair of binomials that must be subtracted with one another. And I only say that this is a little bit more difficult because in this case we have some terms that don't match. For example, this 4x to the 6th power does not have any other variable that matches. So for our answer, technically what we have is 4x to the 6th power minus 0, minus nothing. So we will leave that as 4x to the 6th power. Then we can look at this x cubed and see that those two variables match, so we can combine those as like terms. 3x squared minus 6x squared leaves me with a negative 3x. I keep saying squared, I meant cubed. 3x cubed minus 6x cubed leaves me with a negative 3x cubed. And then lastly, this term over here is a 3 with no other terms to combine with it, no other like terms. Again, you must be very careful and look at the signs that go with the problem. This is a subtraction problem. So in essence, I had no whole numbers on the left polynomial. There were no whole numbers over here on the left side. So I had nothing take away 3. So 0 minus 3 is what you need to be thinking in your head. That leaves me with a negative 3. So the result of these two binomials being subtracted, in fact, is a trinomial as a result. We'll talk about some examples of these in class tomorrow. When it comes to multiplying terms, basically our job is to distribute if we have large polynomials. But to start off, let's just introduce what happens when we multiply simple terms. 3x times 2x, for example. When we multiply terms, we combine the portions that are the same. So in this case, we'll combine coefficients. 3 times 2 is 6. And then we'll combine variables. X times x is x squared. If I had 2x squared times 4x to the 3rd power. Again, combining the same parts. So 2 times 4, our coefficients multiply to make an 8. And x squared times x cubed, that would leave us with an x to the 5th power following our exponent laws. We can distribute in case we run into larger problems. So let's say a 2x monomial needs to be multiplied by a trinomial, 3x cubed plus 4x squared minus 2. Well, the distribution property says that this 2x, this coefficient out front here, multiplies by every term on the inside. And that'll leave me with 2 times 3, 6, x times x cubed, which is x to the 4th, 2 times 4, which is 8, x times x squared, which is x cubed, 2 times negative 2 is negative 4, and x times the hidden x to the 0 power is simply x by itself. The result of this product by distribution, 6x to the 4th plus 8x cubed minus 4x. We'll talk about multiplying expressions using the FOIL method if we need to tomorrow. Otherwise, we will work on examples on page 152, numbers 1 through 5. This comes from a textbook that I have, so you may not have access. You probably don't have access to this. We'll distribute that tomorrow in class.